Now, in this video, we will going to take one more problem on projections of lines. Problem number 56. Draw the projections of a line capital PQ and find its apparent length, and true inclinations with HP. When the line capital PQ has its end P is 25 mm above HP and 20 mm in front of VP, and the distance between the end projectors of the line when measured parallel to the line of intersection of HP and VP is 60 mm. The NQ is 50 mm above HP and the line is inclined at 30 degrees to the VP. So this is the problem he is given. So first we're going to analyze on 3D. So he says a line capital PQ has its NP is 25 mm above HP and 20 mm in front of VP. So when you look from the front view, we can see the distance 25 mm above HP. That image here you can see that distance is NP, which is 25 mm above HP. So this is capital P. When it is projected on the vertical plane, which is at a distance of 25 mm above HP, and this point is called P dash or capital P. And 20 mm in front of VP. So when you look from the top view, we can see the distance in front of VP, that is this distance. When it is projected, that is projected onto the horizontal plane, which is small p, which is 20 mm in front of VP. So you will going to get this point, capital P. And the distance between the end projectors of the line when measured parallel to the line of intersection of HP and VP is 60 mm. So then, and the NQ is 50 mm above HP. So here you take NQ, which is 50 mm above HP. So when you look from the front view, we can see the distance NQ, which is above HP by 50 mm. And you measure the distance and draw a locus of Q in the front view because of the distance of NP above HP by 50 mm. And the line is inclined at 30 degrees to VP. So the inclination of the line with respect to VP can be seen in HP. So because it is a true inclination, so 30 degrees to VP, so you're going to get this line. But here what happens is we have we know the distance between the end projectors. So when you take the distance between the end projectors with 60 mm and draw a vertical line from this projector P, it will going to cut the locus of Q in the front view, which is at this point. So you will going to get Q dash, then join P dash, Q dash with a dark line. So you will going to get the front view. Once you get the front view, so naturally we will going to get the true inclination in the top, true length in the top view, because we know that when the front view line is parallel, its corresponding top view will be in true length. So, but the true inclination is given with respect to VP. So inclination with respect to VP can be seen in the top view. So here, when we rotate the front view, that is P dash, Q dash, you rotate such that both P dash and Q2 dash will be above HP by 25 mm. So once you get this point, so from here you draw a vertical projector to the down, and then from here draw a vertical projector in the horizontal plane, and then with P as center, you measure an angle of 30 degrees and draw a inclined line so that it will going to cut the end projector at this point. You mark this point as Q2, then draw the locus of Q in the top view now. So you are going to get, this is the locus of Q. So here you will going to get small Q2, and also join P and Q2 with little bit thicker than the XY line. And you mark this point as capital Q2 because that is the true length. So now how exactly it will going to do that? So here what happens is we are rotating the top view point. So once you are rotating from Q1, so here we need to, when you go for the three-dimensional analysis, we will not be exactly getting this particular point. That is basically because we have not found the true length in the vertical plane. So to find out the true length in the vertical plane, now we have found out only the true length in the horizontal plane. So how we have found out the true length in the horizontal plane? We have the front view, but we don't have the locus. So that is the reason why we will not be able to get the line in space at this juncture. Now to do that, so first we have the true inclination with respect to VP. So we got the locus of Q in the top view. Now, once we get the locus of Q in the top view, but we know the distance between the end projectors on this line. So here you project the end projector point on the top view also, so that it will going to cut the locus of Q in the top view. So you're going to get small q. Then join P to Q with the dark line. So now we got the top view also. But to find out the front view true length, so with P as center, taking the radius of PQ, you draw an arc such that both P and Q1 will be in front of VP by 20 mm. So now PQ1 is the line which is parallel to VP. So then you project this point onto the vertical plane. So here, which will going to cut the locus of Q here, so that you will going to mark this point as Q1 dash, then join P dash Q1 dash with a dark line with little bit thicker than the XY line. So that will, because since PQ1 is the line which is parallel to VP, so you are getting the true length in VP, and you measure the inclination of this with respect to HP, that is the true inclination with respect to HP, which is theta, which will be 20 degrees when you are doing it in manual. When you are doing it in computer, it will be 19.46. So this is the concept. So once you get this is the true length, now we can get the, as we know that it is 20 mm in front of VP when you look from the top view. So P capital Q1 is the line which is the true length. So here this line is in true length. So what we can do now, we have the locus of Q here. So with P as center, taking the radius of PQ1, you rotate it such that this Q1 will going to come and touches the locus of Q here. So you will going to get this point here. So this point will going to be capital Q. So now when you are rotating in space, obviously that rotation can be seen in the horizontal plane. You can see that it is already rotated, and you make it this line. Now this is the point. So this line will going to be the PQ, which will be in actual line which is in space. Similarly, with P as center, taking the radius of PQ, you draw an arc such that it will going to be both P and Q2, capital P and capital Q2 is above HP by 25 mm. Then you will going to get, this is the true length, P capital P and Q2 is in the true length. So obviously the small PQ2 is the line which is will be in true length, because this is the parallel to HP. Since it is parallel to HP, so you are getting the true length in HP. So now here, how we can see that image in the vertical plane, you can see that P dash Q2 dash is the line which is parallel to HP. Since it is parallel to HP, and we can see the true length in HP here, which is PQ2. So this is how we can analyze it in 3D. When you are going it in manual, stepwise, we can see here. First, initially, what we can do, what we will going to get is, so we have 50 mm above HP. So now we have the point P, which is 25 mm above HP and 20 mm in front of VP. And you have Q, which is above HP by 50 mm. And we have the locus of Q in the front view. And now you know that the distance between the end projectors is 60 mm. So from the vertical projector P, you measure the distance of 60, and then you draw a vertical line and you extend that to the top view. But since we know that the locus of Q in the front view, so always it cuts the locus of Q here. So you mark this point as Q dash, then join P dash Q dash with a dark line. So this will going to be the front view. But we know the true inclination with respect to VP. Since the true inclination with respect to VP is given, so obviously the true inclination can be seen in the horizontal plane. So the image what we get in the horizontal plane is always the top view. So if the front view line is parallel, accordingly the top view line will be in true line. So apply that concept with P dash as center, taking the radius of P dash Q dash, you draw an arc such that both P dash and Q1 dash is above HP by 25 mm. Once you get the above HP by 25 mm, that means both P dash and Q1 dash is parallel to XY line in the front view or parallel to HP. So since it is parallel to HP, so we are getting the true length in HP. So draw a vertical projector from Q1 to the top view, but still we have not got the locus of Q in the top view. So with P as center, you take the true inclination with respect to VP, which is given as 30, then draw a line which cuts this end projector here. So you will go to get the point small q1. So since this line is parallel to HP, so therefore you will go to get this as capital P and capital Q. Join PQ1 with little bit thicker than the XY line. Now you draw the dash dot line, which will going to be the locus of Q. Once you get the locus of Q, we know that the distance between the end projectors in the front view and top view will going to be lying on the same line. So this Q dash, so since it touches the locus of Q in the top view here, so obviously this will going to become small q. So that we will going to explain here. So we have small q here, join P to Q with a dark line. So once you do that, now we need to find out the true length in the vertical plane. So to find the true length in the vertical plane, with P as center, taking the radius of PQ, you draw an arc such that both P and Q2 will be in front of VP by 20 mm. So now the line is parallel to VP. Since the line is parallel to VP, you are getting the true length in VP. So from Q2, you draw a vertical projector so that it will going to cut the locus of Q in the front view here. Since this line, the top view line is parallel to XY, its corresponding front view will going to be in the true length. So this will going to be P dash and this will going to be Q dash. So Q2 dash. So obviously, since this line is parallel, so this will be capital P and capital Q. So join P dash to Q2 dash with little bit thicker than the XY line. So this is how you will be able to find the true length and its inclination. So that the true inclination theta will be equal to 20 degree when you're doing it in manual. So this is how here what happens. So we are rotating and we make it parallel. So that is the line which we have shown here, which is going to be parallel to VP. So you are getting the true length in the vertical plane. So this is how we will be able to analyze this problem in 3D and also in the stepwise. Now we will going to solve this problem by using the sketchbook. First we will going to draw the XY line and mark VP and HP. So we will going to take the distance above HP is 25 mm. So above HP distance is seen in VP. So from XY line, you measure 25 mm above XY line and draw a horizontal line. Similarly, 20 mm in front of VP. So from XY line, you measure 20 mm below XY line and you draw a horizontal line. Consider any point and then from there, you draw a vertical line so that it is going to intersect both the horizontal lines. Then in the VP, you mark this as P dash. In HP, you mark this as small p. Then you make it as capital P in bracket and here also capital P in bracket. Then he says the NQ is 50 mm above HP. So from XY line you measure 50 mm above XY line and draw a horizontal dash dot line which will going to be parallel to XY line in the front view. Because 50 mm above HP distance can be seen in the vertical plane, so VP is above XY line. So from XY line you draw a line parallel to XY at a distance of 50 mm from XY. This will going to be the locus of Q. Then we know that the distance between the end projectors is measured parallel to the line of intersection of HP and VP is 60 mm. So the distance between the end projectors, so this is the projector 1 and this is the projector 2. So the distance between the end projectors measured parallel to the line of intersection of HP and VP. So this is the line parallel to this is the line intersection of both HP and VP. So that this line parallel to this. So from here to here, this line is 60 mm, which is parallel to this line. So 60 mm. Then when you project this to the front view, it will going to cut the locus here. So you're going to get Q dash. But you will not going to get the locus of Q here directly because the locus of Q still it is not been able to find in the top view. So therefore, you draw a vertical projector from Q dash to the top view below the XY line. Then you know that, so this is the problem. Now he has given the true inclination with respect to VP. So the line is inclined at 30 degrees to the VP. So that means the line, it is the true inclination line. So the line is inclined to VP at 30 degrees. So we know that it is the true length in the top view means the front view line has to be parallel. So which is the front view line, which is P dash Q dash. So with P dash as center, take the compass and you with P dash Q dash as the radius, you draw an arc such that P dash and Q1 dash will be above HP by 25 mm. So you mark this point as Q1 dash and then from Q1 dash you draw a vertical projector to the top view. So this is the line which is parallel to HP. Since it is parallel to HP, so you are getting the true length in HP, but we don't have the length, but we know the inclination. So from P, using the protractor, you measure an angle of 30 degrees in the clockwise direction and then draw an inclined line such that it will going to cut this end projector here. You mark this point as Q1 and then draw a dash dot line parallel to XY line. So you mark this point as capital Q in bracket and this will going to be the locus of Q. So join P and Q1 with little bit thicker than the XY line. Now once you get this, now we have once you get the locus, we know the distance between the end projectors. So obviously the distance between end projector will going to cut the locus of Q here and you mark this point as small q. Then join P and Q with a dark line. Then with P as center, taking the radius of PQ by using the compass, you draw an arc such that both P and Q2 will be in front of VP by 20 mm. So now PQ2 is the line which is parallel to VP. Since it is parallel to VP, so you are getting the true length in VP. So from Q2, you draw a vertical projector to the front view such that it will going to cut the locus of Q in the front view here. And you mark this point as Q2 dash. So we know that PQ2 is parallel to XY line in the front view. So in the top view, obviously its front view will be in true length. Therefore, you mark this as capital Q in bracket and join small p dash and Q2 dash with little bit thicker than the XY line. Then show the dimensions as shown. Then you measure this angle theta, that is from P dash by with respect to the horizontal. You measure the angle by using the protractor. Therefore, theta value will going to be 20 degrees when you are doing it in manual. When you are doing it in computer, it will be 19.46. Then you measure the true length of this. So here by using the scale, you measure the length of PQ1 or P dash Q2 dash. Both will going to have the same length. So that will be equal to 75 mm when you are doing it in manual. When you are doing it in computer, it will be 75.05 mm. So then also we need to determine apparent length. What is the apparent length? Apparent length means P dash Q dash, the length of the front view, which is 65 mm, and also PQ. It is 70.77 when you're doing it in computer. When you're doing it in manual, it will be 71 mm. So this is how you will be able to solve this problem by using, solve this. You can analyze and solve this problem by using the sketchbook. Thank you.